and welcome back to AGT STEM. Today we're going to be watching a video about sulfur. So, without further ado, let's hop to it.
Okay, so we take the top off, we'll add a match.
The barking dog experiment was one of the most famous experiments and favourite experiments that was done by my former colleague, Colonel B.D. Shaw.
So Neil's preparing for one of our favourite reactions. It's called the barking dog reaction. This is a reaction which actually makes an element, and we're going to make some sulfur today. So the reaction's quite cool.
In the barking dog experiment, you have a mixture of the molecule carbon disulfide, CS2. It's just like carbon dioxide, but wait a minute.
So this is a test tube, a rather large test tube of laughing gas, N2O, and we're going to use that to make some sulfur.
So I have a model here. So it's CS2, which has a carbon in.
It's funny how all of his models look like they were made from things that he just found around his house. Like he's got a baseball, and these, they kind of look like a dog toy. Probably not, but it's just what it looks like.
In the middle, and sulfurs at either end. So it looks just like in the model as a molecule of CO2, but it has sulfur there and there. And this molecule, CS2, will react with laughing gas, N2O.
So where are we going to do this then?
In the dark somewhere.
So essentially you're just using the laughing gas as a source of oxygen to burn this molecule.
Well, the reaction that we're going to do generates a lot of light. It used to be used as a flash for cameras and for photography.
What happens is you get a very bright emission of a sort of bluish purple light, which in the old days was used for taking photographs. Before people had flash lamps on their cameras, they would set this off and it would give a great flash of light which could be used to take photographs. But because it's much slower than the flash, it makes people really have quite a surprised look. And this may well be why in old photographs people look so surprised, because my God, this thing has gone off, whoosh!
So we're on the hunt for a very dark place.
In the tube, as the reaction takes place, it generates heat.
Okay, so we'll come into the small lecture theatre, which is vacant now. It's quite nice because we can turn all the lights off and make it a bit darker so you can see this reaction in its sort of best. So we've managed to create a darker environment so we can really see the benefits from this chemistry. And Neil's put some water in the bottom of the tube, and we're going to put about 6 to 8 millilitres of carbon disulfide into this tube, and a good mix so you can ensure that we get all of that carbon disulfide going into the vapour phase, so it'll react really quite quickly with that oxidant, the N2O.
As the flame goes down the tube, it accelerates because the reaction is going faster and faster, so it gives this great sort of whoop noise.
Now then, that was a really energetic reaction because the organic and the oxidant are all in the...
It's so loud. It sounds like one of those like supersonic sounds. I don't know what I'm talking about, but like it's a bit like a big boom.
Same phase, and the reaction got a lot faster, and the noise it made went a lot louder as it went down because of pressure. So what you can see in the tube here is actually the result, or the aim of our chemical reaction today, because we wanted to make some sulfur. So what we've got here, coated on the inside of this tube, is a thin layer of polymeric sulfur. So you can see all this really quite nice sulfur coating the side of the glass flask itself. Now I'm really fortunate because I'm just going to go back to my office and prepare a lecture and leave Neil to clean this. We'll just, yeah.
What are you doing, mate?
Well, I've just filled up my vessel with some oxygen. So this is liquid oxygen, which we made for an earlier demonstration, and we just...
What is he doing? What's he gonna do? Is it gonna be like an explosion like the other one, or is it gonna like set on fire or something? Who knows with these people? They light things on fire, they make things explode. It's crazy.
Use it to to drive off all of the non-combustible nitrogen from inside this glass vessel. Oh, look at all that oxygen floating around the bottom of that flask. That's really cool. All oscillating. And a really nice experiment.
It's cool looking.
Yeah, it's a really quite crazy jar. It's a small amount of sulfur or sulfur that we've decanted out, and unfortunately when we decanted it out we spelt the name wrong. So.
Who's responsible for that?
It's a very old friend of mine, and I couldn't possibly give you his identity because he'd be really, really angry, wouldn't he, Neil?
No, I'm saying nothing.
And it wasn't Neil.
It wasn't me.
So here we got a small amount of sulfur that we're going to put on the tip of this
Sulfur or suffer?
spoon. So you can see it's starting to melt over the top, so it's on fire, and then we'll just drop it into the flask.
Wow.
And you can see that sulfur's burning really intensely now with a really quite beautiful flame. It's generating a lot of SO2, really smelly, which is why we're doing it inside this fume hood. But you can see the really rich, intense blue flame as that sulfur is burning in that excess oxygen atmosphere.
Okay, so this is actually a sort of geological sample of sulfur. So you can see it's actually on the bottom. We've actually got a rock, and the sulfur crystals have actually formed on top of it.
It's cool looking. It almost looks like a sponge.
So actually, sulfur does occur naturally. I think it's been known since ancient times. When sermons are delivered with fire and brimstones, because the hell is supposed to smell like sulfur, which is brimstone. But actually, sulfur itself doesn't actually smell. But what you're smelling, the sulfury smell, is actually sort of oxidized material and hydrogen sulfide.
Well, it's actually a mixture of sulfur and sand that was picked up by one of my colleagues on his honeymoon. You see, he was thinking about chemistry even on his honeymoon.
Well, he could have been thinking about the chemistry between him and his wife.
Though I don't think he told his wife that.
I have a feeling, but I could be wrong, that this actually, I bought this sample in Oxfordshire, where I used to live, and I think it's actually from Brazil. But I could be wrong.
So as we're using up all the sulfur now, the flame will die down until it'll eventually go out. Cool, there you go.
Bye bye. Thank you so much for watching, and we'll see you next time. Stay smart. Bye.